Researchers have developed an automated 3D printing method that can produce multicolor 3D microstructures using different materials. The new method could be used to make a variety of optical components including optical sensors and light-driven actuators as well as multimaterial structures for applications such as soft robotics and medical applications. Combining multiple kinds of materials can be used to create a function that cannot be realized with a single material, said research team leader Shoji Maruo from Yokohama National University in Japan. Methods like ours that allow single-step fabrication of multimaterial structures eliminates assembling processes, allowing the production of devices with high precision and low cost. In the Optical Society (OSA) journal Optical Materials Express, Maruo and colleagues described their new 3D printee. Their technique is based on stereolithography, a 3D printing method that is ideal for making microdevices because it uses a tightly focused laser beam to make intricately detailed features. The ability to make multimaterial microscale optical elements using 3D printing could aid in the miniaturization of optical devices used for medical treatments and diagnoses, said Maruo. This could improve the ability to use these devices in or on the body while also enabling them to be disposable, which would help provide an advanced and safe medical diagnosis. Optimizing color stereolithography. Stereolithography builds up a high-precision 3D structure by using a laser to hard. Microfluidics are often used to hold the liquid resins, but it is challenging to keep the different resins from contaminating each other when switching materials without creating large amounts of waste or forming air bubbles in the printed object. In the new work, the researchers developed a way to hold the various materials in a droplet state, which allows them to be more easily exchanged in a closed space such as a microcanal without creating waste. To suppress air bubbles, the 3D printed structure is moved around inside the resin each time a resin is replaced. They also integrated a two-step process for cleaning the 3D printed structure when the resins are changed to completely prevent cross-contamination. To implement this optimized approach, the researchers created a pallet to hold multiple resins and placed it, two cleaning tanks and an air-blow nozzle on a motorized stage. All the processes, including 3D printing, resin replacement, bubble removal and cleaning are sequentially carried out using software we developed, said Maruo. This allows multicolor 3D microstructures to be created automatically. Creating multicolor 3D structures. The researchers tested the approach by placing various types of photocurable resins in a pallet and using them to create 3D microstructures. For one of these demonstration structures, a tiny multicolor cube just 1.5 mm across, the 3D printing system exchanged 5 colors of resin 250 times during a 6-hour fabrication process. The researchers also showed that adjusting the number of layers of multicolor resins made it possible to adjust absorbance of each part of the structure, allowing them to create microstructures with colors such as black by combining layers of red, blue, green and yellow. This method can be applied not only to multicolor resins but also to a wider variety of materials, said Maruo. For example, mixing various ceramic micro or nanoparticles with a photocurable resin can be used to 3D print various types of glass. It could also be used with biocompatible ceramic materials to create scaffolds for regenerating bones and teeth. The researchers are now working to shorten the time required for processes such as resin replacement and bubble removal to allow for even faster fabrication. They also plan to use technology they previously demonstrated to build a multiscale fabrication system in which the fabrication resolution can be changed from less than a micrometer to several tens of micrometers by modifying the focusing lens and laser exposure conditions. Story source: materials provided by the Optical Society. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.